The City Ringen is the new underground line that will link the whole of the centre of Copenhagen and Frederiksberg, which currently has a single public underground transport system. The City Ringen can actually be considered part of a larger transport network, linking the city of Copenhagen with Sweden by Öresund Bridge and the new underground line Malmö.
Öresund e la nuova linea metropolitana di Malmö.
Once the work is completed, there will be 17 stations, all underground, 4 service shafts, a command center and a train depot.
Centro di controllo e deposito dei treni.
The stations are about 1.5 kilometers apart. The total length of the line is about 15 kilometers, and trains will travel at an average speed of about 40 kilometers an hour. Each train has 3 carriages, and their frequency is high, about 3 minutes between one train and the next. Trevi is here to carry out all the foundation work in the City Ringen project, in its capacity as subcontractor to the consortium Copenhagen Metro Team, CMT.
Copenhagen Metro Team, CMT.
The decisions made by Trevi to use certain technologies were guided by the need to excavate to different depths on the different job sites. The cutoff which dictated whether we should use one technology rather than another was 28 meters. For the stations where we needed to reach this depth, we chose to use our cased second piles, CSP technology. For all the other stations where we had to go deeper than 28 meters, we opted for our hydromill technology with panels. Broadly speaking, the geology of Copenhagen is relatively uniform. It basically consists of a top section of flood material with layers of sand, mud, clay of glacial origin. Within this section, we actually found some erratic boulders, which were generally between 30 and 40 centimeters and over a meter long.
30-40 centimetri fino oltre al metro.
Below this glacial layer, there is a bed of limestone which Copenhagen is built on,
Su cui sorge Copenhagen, che ha caratteristiche,
and whose characteristics vary depending on the depth. Our most significant finding was that inside these layers of limestone there are other layers, large and small, going from a couple of centimeters to a couple of meters, of an extremely hard material which is very difficult to break through. It is quartz, which here is called flint.
chiamato comunemente flint.
The first stage in building the piles with CSP technology is to construct guide walls which will help center and align the piles. The second phase involves positioning the machinery in the casing, a crucial operation if we want the piles to be perfectly vertical. Drilling involves the independent counter-rotation of the casing and continuous flight auger rotary tables. The pouring of the concrete is monitored by the Soilmec drilling mate system, which controls the withdrawal of the blades according to the cubic meters of concrete injected. When pouring is complete, the casing and blades are extracted and the reinforcement cage is inserted. In built-up areas like Copenhagen, the CSP method is a cleaner process than bored piles, with no waste. As we needed to build structural diaphragm walls up to 45 meters, we decided to use hydromill technology. The process involves a number of stages. First, we perform a pre-excavation up to about 3.5 meters, so we can couple the slurry pump. The ground is dug as the wheels fitted with picks rotate, pick up the soil and rocks. As we dig, the pump sucks up the slurry and conveys it to the desander, which cleans it and then sends it back to the excavation site. The operator controls the verticality of the dig in real time using the DMS. When excavation is complete, the slurry is replaced with another kind of slurry, whose characteristics are ideal for pouring the concrete. The reinforcement cage, made up of 4 or 5 sections, is jointed and lowered into the shaft by a crane. Once the cage is in position, a platform is placed at the mouth of the shaft and a pipe is inserted, through which the concrete is poured. Despite the complexity of the project and the difficulties posed by the geology of Copenhagen, we have had some excellent results with the hydromill. Obviously, when faced with the unusual situation of this extremely hard ground, we immediately put our heads together to think of a way of getting through it. Because both the second pile system and the milling system have limits of hardness that go from 4,000 to 5,000 kilos per square centimeter, this was an almost insuperable obstacle, and we had to adopt a completely different approach. So how did we solve the flint problem? It was actually quite easy. We decided to exploit its weakness, its fragility. By hitting down on the layers of flint with very powerful tools, we managed to shatter it so the mills and the CSP system could get through it relatively easily.
La frantumazione del materiale quindi ha consentito alle frese e al sistema CSP di attraversarlo con una relativa facilità.
Quality control is in charge of checking the foundation works, such as the pile diaphragms and small drilling jobs, or jet grunting and micropiles. In real terms, we have to check the materials we use on site, the concrete, cement, pile and diaphragm reinforcements, and the verticality of our work. Once again, on this project, Trevi has maintained high-quality control standards, establishing an excellent relationship of trust with both the client and the main contractor. Safety has always been a top priority for Trevi, and its primary objective is an accident-free job site. No accidents on site means the workers are always the center of attention, and that the focus is on safety first, and that the workplace is a safe place where everyone can accomplish their task in any condition. Trevi uses 2 key instruments to reach this goal: prevention and sharing. Prevention is achieved through risk evaluation and implementing risk mitigation strategies. Sharing involves training and information at all corporate levels, from the manual worker through to top management. Applying these guidelines on the city ring and work sites in Copenhagen required considerable effort, involving coordination, prevention and sharing on all the project sites. Equally important is the mitigation of environmental impact, an issue Trevi invests a lot of energy in. For Trevi, safety and the environment are and always will be of paramount importance. The Copenhagen project is undoubtedly a great opportunity for Trevi, because it has been such a huge success despite the great difficulties we have had to overcome.
Le difficoltà che sono state affrontate, superate, ma anche dal punto di vista.
But it has also been an important experience of integration on a human level, because we have always, I believe, demonstrated a great fighting spirit and perseverance in taking on, solving and completing the project in the best way possible and within the deadline.
Fare a termine I lavori nel modo migliore e nei tempi previsti.